All right, this is section 11.7. We're going to talk about geometric probability now that we know how to find the area of all of our figures. And so there are 3 warm-up problems here. I'll give you a second to do those. All right, number 1, area of a circle. Pi times my radius squared. And that gives me 27.04 pi, if we want to leave it exact, centimeters squared. Number 2, find the area of a right triangle with a hypotenuse of 18 inches and a side length of 8. Well, because I need the perpendicular height, I know my base is 8. You have to find the height there. And how are you going to do that? Yeah, Pythagorean theorem. You should get a height of approximately 16.124 when you use the Pythagorean theorem. It's not a triple, so you're going to have to use the Pythagorean theorem. You should get about 64.5 inches squared. All right, number 3, I have a rectangle with sides 4 inches and 5 inches that is cut out of a square with sides 8 inches. Find the area that remains. Okay, so we have a square here that are all 8. And inside, I've cut out a 4 by 5. So what I want to know is, what is this in here, that area? The only way to do that is to do the area of the rectangle and subtract that off the area of the square. So my area of my square would be 8 squared minus 4 times 5 for the area of the rectangle. So 64 minus 20. Which would leave me with 44 inches squared. And you're going to have to do that a lot on our problems we do today. Subtract to find area of shaded regions. All right, some important terms. The probability of an event is a measure of the likelihood that the event will recur. Whoops, sorry about that. Let me go back. Okay, it is always a number between 0 and 1 when written as a decimal. Okay. It can be expressed as a fraction, a decimal, or a percent. Okay. It's usually written like this: P of A, where A is the event. And a lot of times we are going to use area, so A for area. Okay, geometric probability is a ratio that involves a geometric measure such as length or area, and that's why we're doing it now, because we just did all this stuff with area. Right, so if I want to find the probability of the event, your numerator is the favorable outcomes. Whoa, let me go back, sorry. Okay, and your denominator is the total outcomes. So what does that mean for you? Okay. What I mean by favorable outcomes is where you want to be. Okay. The denominator is the whole thing. All right. So think about it like a dartboard. If you want to hit the center, okay, that's where you want to be. So the area of that center could be your numerator, but the whole board, the area of the whole board would be your denominator. So we're going to start off really easy here and show this on a number line. Find the probability that a point chosen at random is on the given segment. Okay, we're going to show our answers as fractions, decimals, and percents. So I want to guarantee that I'm on segment BC. Okay, so I need the length of BC on top. That's where I want to be over the whole thing that runs from A to E. Okay, so just count how long is it from B to C. Now be careful because your number line is counting by twos. So 2, 4, 6 units over the whole thing, which is 16. So simplified fraction would give me 3/8, which is 0.375, which is 37.5%. All right, part B, I want to be on BD over AE. So BD is 10 units long. We know the whole thing is 16. Simplify your fraction. So 5/8. Decimal, so divide. So we have 0.625, which would be 62.5%. Part C, I need CE over AE. So C to E is 8 units over 16. So that would simplify to 1/2, which is 0.5, which is 50%. And the last one, AD over AE. So how long is it from A to D? Well, that's 12 units long over the 16. Simplify. Decimal. Percent. Remember, when you change a decimal to a percent, you multiply it by 100 or move your decimals 2 places to the right. I want to find the probability that a randomly chosen point in the figure lies in the shaded region. All right. So when I do my fraction, okay, my numerator has to be the shaded. My denominator has to be the total. Now, they are both circles, okay? So let's find the area of the shaded circle first. What would the radius be? Well, you'll notice that's the other half of the diameter. Okay, so it would have a radius of 3. So I have pi times 3 squared. And the total would be pi times 6 squared. So I have 9 pi over 36 pi. Now, don't multiply by pi, okay? They just cancel. So we're left with 9 over 36, which is 1/4, which is 0.25 or 25% chance that you would lie in the shaded region. Right. Again, I want to lie in the shaded region. So I need the shaded triangle, okay, over the big triangle. Now, we could make this really difficult on ourselves, okay? And we could find the area of the shaded triangle, okay? We could find the area of the big triangle, but let's talk about this. What do you notice about all the triangles? Do you see how every piece is marked congruent? So if all the side lengths are congruent, wouldn't the area be the same for all of them? So when I look at this, I have one shaded triangle out of how many triangles? 1, 2, 3, 4. That's your probability. Look for tricks like that because it can save you a lot of time. Now, that isn't going to work all the time. Like I said, it's just you have to look at your figure. If you notice a lot of congruence, use it to your advantage. Oh, perfect example here. We were just talking about this. Okay, a dart game uses a target with concentric circles. Now what that means is that there are circles inside each other that share the same center. Okay. And the radii are 5, 8, and 12 inches. Okay. So that means inside the red, that has a radius of 5. Okay, on the blue, from the center to the edge of the blue, that would be 8. And from the center to the edge of the yellow, that would be 12. So I want to land in the 20-point circle. So I need, in my numerator, the area of the red over the area of the whole circle. So let's do the red first. It's going to have a radius of 5. Okay, so pi r squared. Okay, and the whole thing, okay, that has a radius of 12. Again, the pi's will cancel, so I'm left with 25 over 144, which is 0.174, which would be about 17.4%. All right, find the probability that a randomly chosen point is in the shaded region. Now you're going to know the shaded region is just those little edges of the circle. So we have to find the area of that because that's where I want to lie. So what we're going to have to do is take the area of the circle. So again, we're going to take the area of the circle and subtract the area of the hexagon. And we'll divide that by the area of the circle. Now, the area of the circle is going to be the easy part, right? It's pi times 7 squared, which gives me 49 pi. Now, we have to find the area of the hexagon, and that's what you spent last week doing. So you have 1/2 times the apothem, which I do not know, times the number of sides is 6, times the side length, which I also don't know. All right. So if you remember, we drew in this triangle here. All right. Find your central angle. So 360 divided by 6 sides is 60. And then remember that is bisected. So I'm just going to redraw half of it here. All right. This is your apothem. All right. So this 60-degree angle is this whole thing. So I know this is 30 inside, so we can use our 30, 60, 90 rules. Okay, so my hypotenuse is 7, okay, which means my short leg is 3.5, and my apothem is 3.5 root 3. Now remember, that's only half of this, so the whole bottom would be 7. All right, so multiply that together. And you should get about 127.3. Okay, and this 49 pi, I'm going to go ahead and change that to a decimal as well. It's about 153.94. Okay. So now I'm going to substitute into this, all right? So we have 153.94 minus the 127.3 over the whole thing, which is a circle, so the 153.94. Okay. So if I subtract, that gives me 26.64 over the 153.94. Don't worry about simplifying the fraction. Divide it, find me the decimal, which would be about 0.173, which is 17.3%. All right, so you are still going to have to use that 1/2 times the apothem times the number of sides times the side lengths here to find the area of these regular figures. All right, so find the probability that a point chosen at random lies in the shaded region. Well, my shaded region is a strange figure. Okay, so we need a plan here. For my shaded region, we're going to do the area of the rectangle and subtract that half of a circle. Now, half of a circle is called a semicircle. Okay. And then the whole thing is the rectangle. Okay. And it just says to express your answer as a percent. So let's do the area of the rectangle. Okay, base times height, 8 times 6. Okay, now I need the semicircle. So literally I'm going to do half of a circle. So half of pi. Now my radius, be careful because the whole thing is 6. So my radius would be 3. So that gives me 4.5 pi, or 9 pi over 2, however you want to put that. All right, which is about 14.137. Now substitute into what we just wrote above. All right, so I have 48 minus the 14.137. over the 48. Right. And you should get 0.706, which would be 70.6%. All right, not too bad. Let's keep going. My goodness, what do we have here? Think of your plan first. All right. My numerator, if I want to lie in the shaded region, has to be the area of the triangle. My whole thing is the square. So that's the two things you need the area of. All right, so let's do the area of the square. It's 8 squared, or 64. Area of the triangle, 1/2. Now the base would be here, so it is 8. What's the height? I need this. Well, if this whole thing is 8, and this uses up 5, that means what's left has to be my height, which is 3. Which would give me an area of 12, which would be my numerator. So 12 over 64 would be 3 over 16, which is 0.188, which is 18.8%. So that one was pretty easy. All right, number 7, I want to get in the shaded region. What is the shape of the shaded region? Okay, it's a trapezoid, right? So I need the area of the trapezoid on top. But then I want the whole figure. What is your whole figure? It's the trapezoid plus the rectangle that sits on bottom. That's our plan. So let's find our areas. Let's do the trapezoid. So 1/2 times height times the sum of the bases. That's your trapezoid area formula. Okay. The height is what? Remember, this is 5, so what's left here would be 2. And then I have a base of 7 on top and 10 on bottom, which would give me 17 units squared. Now I need the area of the rectangle. All right, so the area of my rectangle, it's a 5 by 10, which gives me 50 units squared. All right. So let's substitute it into what we have here. The trapezoid was 17. In the bottom, we have 17 plus 50. So that gives me 17 over 67. And that gives me 0.254, which is 25.4%. All right. Last one. This is probably going to be our most difficult problem here, because in order to find the area of the shaded region, which is where I need to be, I need to do the area of the whole circle, subtract off the big circle, subtract off the area of the small circle, and then subtract off, remember that was called a sector, all over the area of the big circle. And that's going to have to be our plan. So here we go. Let's find the area of the big circle. Pi times my radius. So what do you think the radius is of the big circle? Well, look here. The radius of the small circle, I know, which means its diameter is 8. So this whole thing would be half of the other circle. So it's 8 squared, which gives me a 64 pi, which is about 200.96. All right. So this is 200.96. All right. Now I need the area of the small circle. So pi times 4 squared, which is 16 pi, which is about 50.24. And now I need the area of the sector. All right. Then remember that formula. Okay. So remember, it's x over the area of the whole circle. Okay, now we just did the area of the big circle. It was 200.96 equals the degree over 360. Cross multiply and solve. So you have 108 times 200.96 equals 360x, and then divide by 360, and you should get 60.2 288. And then the big circle again down here was 200.96. So subtract, and you should get 90.432 over 200.96. Change to a decimal, which is about 0.45. So it's 45%. All right, so it looks like a big job, but as long as you remember that sector formula down here, okay, it shouldn't be too bad. It's just you have to find the area of a lot of things just to get the shaded part by itself. All right, that's going to be the end of this section. If you have any questions, please let me know. Bye.